Welcome everybody. I just want to talk to you a little bit about uses of radioactivity and sort of revisit a few of the things that we talked about previously with fission and fusion. Radioactivity, we've been sort of giving it a little bit of a bad rap when we talk about fission reaction disasters, radiation poisoning, but it turns out that if, somebody is given radiation in a very small dosage, it could be used to do things like treat cancer. It could be used as what's known as a biological tracer. And so these are some of these types of radioisotopes that are used in medicine. So iodine-131 is a big one. This is actually used to either treat the thyroid or to study its function, because the thyroid does use iodine in its production of thyroxine. If you want to study red blood cell function, you can use iron 59 that gets incorporated into hemoglobin. Phosphorus 32 can be used to study eyes, liver, tumor. In a normal lab, you can also incorporate phosphorus into DNA, into that phosphate backbone of the DNA, and you can basically what they call radio-label it. Technetium-99, that's used to study the heart, bones, liver, lungs. Sodium-24 is for the circulatory system. Now, some other uses of radioactivity that come up on the Regents exam: carbon-14. This is used to study fossils. It has a half-life of about 5,700 years. And so if you find the remains of an organism, you can determine how old it is based on how much carbon-14 remains in the fossil. Once the fossil dies, it obviously stops eating and stops incorporating fresh carbon-14 into its system, and at that point it's sort of like time-stamped. And so if we find the remains of an organism from thousands or hundreds of thousands of years ago, we can determine its age pretty precisely based on this type of radio dating. Another isotope, uranium-238. This is used for dating rocks. So if you're into dating rocks, geology, you might have learned about this in earth science. And this has a really long half-life of about 4 billion years. And so this makes perfect sense to use for dating, something that is extremely old, like a rock formation, to see, like how old the Earth is, for example. Another use is, or another isotope is cobalt-60. This is used a lot in cancer treatment. So the cancer cells are growing uncontrollably. If you target the cancer cells with a really fine beam of radiation, you can irradiate those cancer cells. And so this is used as a cancer treatment. Cobalt-60 and other isotopes can actually also be used to sterilize food. And so if you bombard food with this, with the radiation, then it will kill microorganisms, make it safer to eat. You're not adding it to the food, you're just exposing the food to the radioactive rays, which doesn't make the food radioactive. It just kills any organisms that are there. Okay, so these are some common uses. The Regents likes to bring this up quite a bit. Some interesting stories about radiation. Sometimes if you're giving off these particles, you'll cause there to be some kind of glow. And so they actually used radium-226, this isotope, in watch dials when they wanted them to glow. And this happened in the early 1920s. And a couple of interesting facts about this. This would make the watch hands glow so that you could see them in the dark. This has been largely replaced by fluorescent, phosphofluorescent glowing bands, which are not radioactive. In some cases, tritium, which is much less potent than this radium-226. And there's actually some interesting stories about what they call the radium girls. And there were all these women working in these watch factories, and they were painting the bands with the radium paint. And a few interesting things is they thought it was cool, and they were told that it was completely harmless to them. So some of them would use it as makeup or to paint their face. And actually, what's really interesting is they were instructed by their employers to sort of make the tip of the paintbrush, to prop it up again. They were told to dab it against their lips instead of on like a piece of paper or washing it because it would waste less paint. And so a lot of these women were, exposed to high levels of radiation, and either they died or they got really sick. And this was sort of one of those cases of workers' rights, during the Industrial Revolution and after that, where, people were not really protected, and they needed to sort of, fight for proper working conditions. I had mentioned radon before, and radon is a noble gas. It's non-chemically reactive, but it's radioactive. It decays and it gives off particles, and it can cause, cancers when people are exposed to it in long periods of time. So, like this is showing you some of those radon maps, and I had mentioned Pennsylvania. Pennsylvania's over here, and it has like a high level of radon. And then in any other parts, usually there's like a bedrock base, where people are basically digging out a basement, and when they do that, then they're exposing themselves to radon. And so if you ever buy a house in a region where it's known to have radon exposure, you should always have that house tested, to make sure that you don't need to either not buy the house if you're that concerned, or have some kind of mitigation system put in where it will sort of the ventilation system will remove the radon from the home so that you won't be exposed to it. I had also spoken about safety with nuclear power plants and had mentioned Yucca Mountain to you. And Yucca Mountain is, this one-stop storage place where, people would store huge amounts of radioactivity and try and keep it sequestered. But there's controversy about this. Like, do we want to store the radioactivity in one spot, or do we want to spread it out in different spots? Depending on what your philosophy is and what you think would be wise, that's a big controversial topic. I had spoken to you a lot about nuclear accidents with Chernobyl. This is actually a picture of Chernobyl. This was after the accident occurred. You can tell that there's this area here that's sunken in. And what was interesting about Russia is that they try to cover this up with a really quickly, hastily made, poorly made, I would say, what they call the sarcophagus. And so this building, it was teetering on the edge of falling down for many years. And so very, very recently, they're constructing a new sarcophagus that is going to be, more stable and more state of the art. It's going to protect the area around it from radiation. All right. Well, thanks so much for watching this nuclear chapter presentation. I happen to really enjoy teaching nuclear chemistry. I just think it's really relevant and important for you to understand the science behind it. You can make your own opinions about what you think about nuclear power, and whatnot, but understanding the science and sort of having an idea of an idea in which you can actually, base your opinion on, not just, what you hear randomly here or there, but what actually you truly understand. That to me is really important. All right, thanks so much for watching.